Hi students, good evening. Welcome to this video session. I remain Samuel Chukwu Emeka, aka Sam Dump for Peace. In this video session, we shall discuss the normal probability distribution. So I am on the notes tab of the statistics section. Please, it is important that you view the videos on probability distributions, that you view it in order. Okay, it's a playlist. It is important that you view it in order. And these are the prerequisite videos here. It is also necessary that you view the z-scores and the empirical rule. In this video, we shall use the normal distribution table, and we shall use the left shaded area. So if you click on the resources section, you will see the left shaded area here. And I got this from the University of Florida, the table here. Now, we have a simplified form. We also have the center shaded area, and we also have the right shaded area, for the normal distribution, of course, which are the critical values. But I'm going to use the left shaded area in this video. Why? Because most textbooks use the left shaded area. Now, some textbooks use the center shaded area. This one I got it from the US government. This is the center shaded area, where it is between 0 and z, 0 in the middle and z. Some textbooks use the center shaded area, but most textbooks use the left shaded area, of which it is left shaded area. Some use the right shaded area, but for this video, we will use the left shaded area. Now, if your textbook or your professor uses the center shaded area, just let me know. And if you do not understand it, just let me know. I can explain it to you. Then the technology we shall use the StatCrunch software from Pearson. We shall also use the Microsoft Excel. And if you don't have money for StatCrunch and Microsoft Excel, well, all you need is a Gmail account, and you can use the Google spreadsheet. Okay, we can use those. So, but this will be in another video. We will not have time to do all this technology in this particular video. So this is just part 1. Watch out for other parts. We shall discuss the normal probability distribution, and we shall solve real-world applications involving the normal probability distribution. Now, let me explain this table for a moment, okay? So, with the standard normal probability, actually, here, standard normal probability, standard normal distribution, or you can say standard normal probability distribution. It is also known as the z-distribution, or some textbooks will refer to it as the unit normal distribution. The mean is 0 and the standard deviation is 1. And this is the standard normal probabilities. So what we actually do is we convert to z-scores and then we find the probabilities here. Let me explain what I mean. So I will pull up my notebook. And I'm going to open up this. I will type in normal probability distribution. Okay. So I'll just call this introduction. Let me draw this here. I choose this. So a normal distribution looks like this. Bell-shaped curve. Okay, this is a bell-shaped curve. And, you know, for the standard normal probability distribution, the mean is 0 and the mean is at the center. Okay, it is 0. And don't worry, I will review this again. I will talk about it again. So the mean is 0. Now, to the left of 0, from your number line, okay, if you look at your number line, your real number line, 0 is at the center. 0 is neither positive nor negative. 0 separates the positive numbers from the negative numbers. To the left of 0 are the negative numbers. To the right of 0 are the positive numbers. So the same thing goes with the normal distribution. It's a bell-shaped curve. The mean for the standard normal distribution, the mean is 0. Okay, because the table we are using is the standard normal distribution. So the mean is 0. And as you can see, to the left of this 0 are the negative. So that's why you have the negative z-scores here. Okay, because this is to the left of 0. You have all these negative z-scores. Okay, I'm going to show you how to read the table. And to the right here, the next page is to the right of 0. To the right of 0 here, although this is area to the left. Okay, but these are now positive z-scores because this is past the middle, which is 0. Okay. What is normal probability distribution? It is also known as the Gaussian distribution because it was introduced by Carl Gauss. Carl Gauss was a German mathematician. It is the probability distribution used to model the probability of a continuous random variable. Okay, so when you look at that's why we talked about you need the prerequisite videos to understand what these terms mean. Okay, so with the continuous random variable, you can measure it. Okay, it is not discrete, it is continuous. Now, it's something you can measure. Some applications of normal distributions are seen in variables such as the shoe sizes of the students at Georgia Northwestern Technical College. So, you know, if you look at this, let's get back to this. Okay, if you look at this now, the normal distribution curve. Okay, so if you look at, this is the standard normal distribution. Let's just draw a normal distribution here. So if you look at the normal distribution table, normal distribution curve. So let's say students at GNTC. You will notice that a lot of the students, okay, their shoe sizes fall on this average. You might notice some students with very small feet. Okay, you might notice some students with very small feet. And, you know, their shoe sizes are very small. Then majority of the students, their shoe sizes are average. Okay, they fall around here. Then you will still notice some students with big feet. Okay, with bigger shoe sizes. The same thing goes with height. Heights of students at JSU, Jacksonville State University. Okay, some students are very short. Then majority of the students are average height. Then some students are really, really tall, 6 feet, 7 feet. Okay, now but few students are short. A lot of students are average height. Then few students are very tall. So that is a normal probability distribution. You look at the IQ scores of the population of Corpus Christi, Texas. Okay, the IQ scores of the residents of Corpus Christi, Texas. Some people, very few people will have low IQ scores. A lot of people will have average IQ scores. Then very few people will have high IQ scores. That is a normal probability. Okay, so we use normal probability distribution to model such continuous random variables that behave that way. Even with your grades, okay, some professors use the normal curve to normalize. They will call it normalizing their grades. Okay, now this is controversial, but if a lot of students flunk their class, then they would want to apply the Gaussian curve or the normal curve. And by the time they finish finding the z-scores and, plotting this normal curve, few people will make D's and F's. Okay, D's and F's will be these folks here. A lot of people will make C's. So which is around these people. And then few people will make B's and A's. Like I said, it is very controversial. I don't use normal curves to grade my students. No, I don't think it is fair to the students. I believe in giving students a lot of opportunities to succeed. And whatever the grade they earn, that is what they make. Okay, I'm not gonna come, and add points or manipulate grades just to normalize it. I mean, that's me anyway. So these are just applications of normal probability distribution, just for you to have an idea. Now, what are the properties of the normal distribution curve? Number one is the bell-shaped curve. As you can see here, is bell-shaped. Okay. Number two, the total area or the total probability or the total relative frequency under the normal curve is 1. So this, when you look at the total area here under this curve, the total area, you can either call it area, you can call it probability, or you can call it relative frequency. So when we use this table, when we begin to use this table, everything you see here, okay, these are the z-scores here in the first column. But every other thing you see here in these columns are what we call the area under the curve, or the probability, or the relative frequency. Okay? The only first column here are the z-scores. The first column and this row here, the first row, they are the z-scores. But under it are now the areas or probabilities or relative frequencies. Just know that it's the same thing, whether you say area or whether you say probability or whether you say relative frequency. Now, if you like we mentioned, you need to view the video on z-scores. Z-scores are rounded to 2 decimal places. Okay, so you in this table, this first column, okay, are the first decimal place, and the first row are the second decimal place. Okay, your z-scores are rounded to 2 decimal places. The first column, they are the first decimal place, and the first row are the second decimal place. Okay, so if I want to find z of negative 2.94, that means I get my negative 2.9 in this column, and I get my 0.04 on this row, and then the probability will be 0.0016. We shall come to that. Okay, so the total area under this curve is 100% or 1. You can call it total area or total probability or total relative frequency. Property 3. It is symmetric about the mean. Okay, it is symmetric about the mean. Symmetry. Now, and the center, the mean is the center of the distribution. Okay, Symmetry means the area under the curve to the left of the mean is equal to the area under the curve to the right of the mean. So we did this in this video, empirical rule. So the mean is the center of the normal distribution curve. 50% is below the mean, okay, 50%, and 50% is above the mean. Okay, this is just for the standard normal distribution curve. Now, even if you're not using the standard normal distribution curve, what this is saying is that the mean is at the center, of course, and it is symmetrical about this mean. Symmetry means that when you divide it into your half of the left area is equal to the right area. Okay, the left area is equal to the right area when you divide it in two. So the mean is at the center of the distribution, and this is symmetrical about the mean. Okay, any normal distribution at all, any normal distribution curve is symmetrical about the mean. Okay, the mean is at the center. Left half area of the left half is equal to the area of the right half. Property 4. The mean, the median, and the mode of a normal curve is the same. Okay? Due to this property, the normal curve has a single highest peak, and that occurs at the mean. So with a normal distribution curve, the mean is equal to the median is equal to the mode. Okay? That is with a normal distribution curve. The mean is equal to the median, and it is equal to the mode. The peak, this peak occurs at the center, and that center is the mean, which is also the median, which is also the mode. Property 5. As x increases without bounds, which means gets larger and larger, or decreases without bounds, gets smaller and smaller, the normal curve approaches but never touches the horizontal axis. So what this is saying is this. Let me erase this here. So we have a large eraser. This is the standard normal. Okay, this is the standard normal, which means the mean is 0. Standard normal distribution. So what this is saying is, that property is whether you have the standard normal or even whether you have the normal. Okay. Now, some of you might ask me, what's the difference between the standard normal and the normal distribution curve? Okay. The standard normal distribution curve, the mean is 0, and the standard deviation is 1. Okay. But the normal distribution curve, the mean can be anything, but the mean is not 0. Okay. The mean is not 0. But the mean can be anything. So, if you look at the normal distribution curve, or the standard normal distribution curve, or normal curve, okay, or standard normal curve, as x increases and increases, okay, as x increases and increases, this curve does not touch. It approaches, but it doesn't touch. It doesn't touch the x-axis. It does not. Or as x decreases, this curve, it approaches but does not touch. Okay, as x increases, this curve approaches but does not touch this x-axis. And as x decreases, this curve approaches but does not touch. It does not touch the x-axis. Okay? Property 6, empirical rule. Please, I have discussed this. Okay, I've done this in video. This is the video I did on empirical rule. Please, you need to view this video on empirical rule. It is very important. Okay, I think I explained it well there. Property 7. The normal curve has the inflection points at one standard deviation from the mean. Of course, one standard deviation below the mean and one standard deviation above the mean. Okay, so when we talk of one standard deviation from the mean, it means one standard deviation below the mean and one standard deviation above the mean. All right. The standard normal distribution. This is also known as the Z distribution or the unit normal distribution. And that is what we will be using for this table. Okay? Because we have to normalize it first by finding the Z-scores. Then we can now use this table. The mean of the standard normal curve is 0, and the standard deviation of the standard normal curve is 1. Now let's solve problems. We will begin with question 5 to solve and continue, from question 5 to question 25. If we don't finish it in this video, then just watch out for the next video, okay? But we are going to solve from question 5 to question 25, and we will use tables, okay? That is why I say view the video for detailed explanation, because, typing all these on notes, will be will be time consuming, and it sometimes is good you say it to see how it's done. So we are doing this on MATLAB, and it's going to be from question 5 to question 25. So if we don't finish all of them in this video, then don't worry, watch out for the next video, okay? And after that, we will solve more problems as well. But I would really like you to grasp this, to understand the concept. Now, find the area, okay? Like I said, the area means the probability, and it also means the relative frequency. Find the area of this shaded region. So this is to the left, okay? And Z is 0.69. So we are going to use the table. Now, 0.69 means for Z to be 0.69, the standardized score or the standard score, 0.69, it means 0.6 under 0.09, under 0.09. Okay, let me just write this, finding areas under the standard normal curve. Okay, so I'm gonna type in here Z equal to 0.69 means 0.60 under 0.09. That is what it means. I hope that was what I wrote here. Yeah, 0.60 under 0.09. Okay, I can go ahead and write this. 0.60 under 0.09. Now, you might ask me how. That is what you might ask me, how. Okay, you want to break, like we mentioned earlier on, the Z-score is 2 decimal places. Your Z-score is 2 decimal places. And with your table here, which many textbooks use, you have 1 decimal place here, and you also have 2 decimal places here. The column, okay, this column, and these are for the negative Z values. We've explained why they are negative. And these are for the second page is for the positive Z values, are for the positive Z values. So this is for the first decimal place, is the first column that you use. And then for the other one, okay, for the other 2 decimal places, you now use the first row of each. So 0.69 means 0.60, or you can say 0.6. Okay, I see that this one wrote this one is just 1 decimal place, which is, which is okay. So let me just use 0.6, okay? 0.69 means, but now you can, some tables will have 2 decimal places on that first column. It doesn't matter, okay? You still do it the same way. 0.6 under 0.09. So whether you say 0. Some tables will have 2 decimal places in the column, okay? So they will have 0.60 instead of 0.6. 0.6 and 0.60 is the same thing. So you look for 0.6 on the column, and on the row you look for 0.09. Okay, so when you do that here, 0.6 is positive, so you don't use this page. You go down to the next page. So this is 0.6 under 0.09, and that gives you the area, or the probability is 0.7549. 0.7549. So I come here and I put 0.7549, and that is it. Okay, that's it. Question 6. This one is the area to the right, okay, and Z is negative 0.87. Okay, the table I gave you is to the left. Okay, it's to the left. And you know, in my in the resources, I also have a table to the right. Okay, you can use this here to find that table to the right. But I don't want to teach you with this unless you want me to. Okay, I want to teach you the most common one that they use. Okay, the most common one that they use is this left shaded area. Not even the left shaded area simplified, no. It is this left shaded area. So the question asked you the area to the right. Meanwhile, the table gives you the area to the left. Okay, the table gives you only the area to the left. Okay, now what would you do? First of all, let's find the area to the left. Then we know that the total area under the normal curve is 1. So we have to subtract that area from 1. So let me show you what I mean here. Let me draw this. Okay, so this is what they want us to find. This is Z. This is Z, negative 1.87, negative 1.87, and they want area to the right. This is the area they want. Okay. Now, I want you to visualize this. Okay, that this area here, I'm gonna draw 2 things here. This hole here minus, I'm gonna draw another one here, and I want you to kind of visualize it. If you're a visual learner, this will make plenty of sense to you. So if I want to find that area, I want to find this area to the right, okay? But I don't have the table to area to the right. Now, but I know that this whole area will give me 1. This whole area is 1. Then this is the one they gave me, area to the left. See that? So if you take this whole area minus this area, this is the one they gave you. Okay, this whole area, which is 1, minus this area they gave you, that will give you this area. Does it make sense? Okay, so now we're going to find negative 1.87, and this will be in the negative page here. So negative 1, and this means negative 1.87. What does it mean? Negative 1.87. Negative 1.87 means, okay, negative 1.8 under 0.07. Okay, that is what it means. Okay, so we're gonna do that. So this is 1 minus, we get this area here, negative 1.8 under 0.07. 0, 1, 2, 3, 4, 5, 6, 7. And that gives us 0.0307. 0.0307. Okay? So, this will be 0.0307. Okay? Now let me kind of be fast on this, so because we have a lot of questions to do. So I'm gonna pull up this calculator. 1 minus 0.0307. So that gives us 0.9693. Okay, and with this, like I said, this video is tables. Later on, we shall solve this with technology. Okay, but I want you to learn it with table, left shaded area. 0.9693, that's the answer. So I come here. This is 0.9693. That's it. 0.9693. Oh, I did negative 0.87. And I did, oh, this is negative 0.87. But I did negative 1.87. Okay. I did negative 1.87. Okay, folks, let's do negative 0.87. Okay. So if it was negative 0.87, I know you say, hey, Mr. C got this wrong in video. Come on. It was because I did negative 1.87. Let's do negative 0.87, folks. So this one is for this. Okay, this one is for this. I'm going to put that this is for this here. So for negative 0.87, I'm going to draw this arrow. So that will be 1 minus. Now let's get a negative 0.8 under 0.07, because that is what it will mean. Okay, negative 0.8 under 0.07. Let me type it here. Negative 0.87 means negative 0.8 under 0.07. Okay, so this will be, please, I really want you to understand this. Okay, let's now get this. So this is negative 0.8, 0, 1, 0, 1, 2, 3, 4, 5, 6, 7. So this is a 0.1922. 0.1922. Okay. So 0.1922. 0.1922. Okay. What would this be? 1 minus 0.1922. That is 0.8078. 0.8078. Okay, now I'll get it. I bet you. 0.8078. Yay! Okay. Question 7 is between. Okay. Now we'll do question 7 and then we'll stop this video for now, for this session, and you just watch for other parts. It will be several. It will be a lot, because normal distribution is much. It's a lot. Okay. Now between, and we are using this table. Okay. We are using the left shaded area, and we need this between. Okay. Let's see how we'll do this. Now this is negative 0.89 and this is 1.25. Okay, folks. I'm gonna add another page here. Finding areas. But finding areas. Okay. Let me just call this part 2. Okay. Negative 0.89 and then 1.25. That was what we have, right? Okay. So let me explain this using the left shaded area. Now this is I come here. This is what they asked us here. This is negative 0.89. Z is negative 0.89. And this other Z is 1.25. Okay. Now this is the area they asked us. And we don't have a table that has between. Now I have it here. I have it between, you see this, that's what you use. But I don't want to use it. Okay, I don't want to use it. I want to use this left shaded area because that is what most schools will give you anyway. Now, this is the way you do this, okay? We'll get that of, you see, let's visualize this. Let's visualize it. I have 1.25 here. Okay. And this is the table they gave us. Okay. All these are shaded, 1.25. You will see that this area here is this area minus, then I have negative 0.89. Okay, I have negative 0.89, negative 0.89. See that? And this is what they gave me. This is the left shaded area they gave me. Okay, so you will see that this whole area minus this small area gives you this area. You see that? So we will find, with our table, we'll find the probability when Z is equal to 1.25, we keep it. Then we subtract also the probability when Z is negative 0.89. Okay, so we subtract this probability from this probability to get this probability, or the area. Okay, because some of you will say, hey, they asked area, why are you saying probability? It is the same thing. We subtract this area from this area to get this area. So let's go ahead. Let's do 1.25. 1.25 means 1.2 under 0.05. Okay. Let me write it here. 1.25 means 1.2 under 0.05. Okay. And then negative 0.89 means negative 0.8 under 0.09. Okay, so we come here, let's get our 1.25, 1.2, 0, 1, 2, 3, 4, 5, and that is 0.8944, 0.8944. So we write it, so 0.8944, that is the probability or the area, minus, okay, minus, then we get negative 0.8 under 0.09. We come over here, the negative 0.8 under 0.09. Okay, and that gives us 0.1867. 0.1867. So we come over here, we write 0.1867. Now let me say this, your probability will never be negative. Never. Your area will never be negative. Okay, so take note of that. Probability is not negative at all. Probability lies between 0 and 1. 0 is the probability of an impossible event, an event that will never occur. 1 is the probability that an event must occur. Okay, so 0.8944 minus 0.1867 equal to 0.7077. So 0.7077 is the answer. Okay, or Or you can say 70.77%, because probability can be decimal or fraction or percent. Okay, 70.77%. Okay, are you with me? So 0.7077. All right, we shall stop here for tonight. Please watch out for other videos on this. And you have a good evening.